Welcome, class. Today's lesson is on balancing chemical equations. It's one of the first foundational pieces of learning how to do stoichiometry, and that particular part is relatively difficult. But in order to get to stoichiometry, one of the things that you're going to have to master is being able to balance your equations. Chemicals react in different ways, and as they do, we need to understand about how those particular elements kind of get together. And by balancing equations, that helps us do that. So I like to use this Jefferson Labs site on balancing equations called Balancing Act. And I think this is a really good website, especially for beginners, because you're allowed to do a lot of practices and you can change things. And I think it's a really good place to start. So that's where I'd like to start today by going over 3 to 5 of the equations with you and kind of walk you through each of the steps so that you can become much better at it. Just like anything else in life, and in particular in chemistry, you're going to have to practice, and practice. So here's a site that I think can do that. The other thing that you could do to gain some good experience is to Google something like balancing chemical equations worksheets. And you get lots and lots of different sites with answer sheets, and so that you can practice on your own and get better at this. So anyway, at this website, I'll just click where it says 5. How many equations would you like? We're going to start with 5. And like I said, we go to 3 to 5 to see how it goes. And then we're going to click on beginner. And I think that's a great place to start. And as you get more confident, you can build up more questions. You can build up your level so that you really can do some of the advanced materials as well. We're going to have worksheets in class, and I'm going to be doing a variety of different levels in class. But I think if you want to take some time, this is a good website to start with. So let's go ahead and click I'm ready. Let's start. And here's our first equation. You can see that here is all of the equation, and we're going to check to see if indeed it needs to be balanced. So one of the things that I like to try to do is I like to go ahead and just take an accounting, if you will, of all the different kinds of elements that are in there. So I'm going to draw a line right here, and we're going to go through each of the elements and count them up. So on this side, I'm going to move down here. Carbon, how many carbons we have? We have 1, and that's all we've got. So we have 1 carbon. So I'm going to put down 1. And I think it's important, especially as you're starting out, not to try to keep this in your head. As a matter of fact, the one thing about this particular website is it doesn't really have you keep track of it. But I would do it on another sheet of paper so that you can follow along. And then this oxygen, we have 1 here, and we have 1 here. So we have 2 oxygens. So write that down. And then you have some chloride. So chlorine molecules, you have 2. And the reason I know you have 2, if you look at the subscript right there, it says 2. And then also we have hydrogen. We have 2 hydrogens. So we're going to mark down hydrogen, and there's 2 of them. So let's look at the same in the same order. We have, in this particular point, we have a carbon, and we have 1. We have 2 oxygens. Again, looking at the subscript right here, there's 1 and there's 2. And so as far as you take a look, you can see we have 1 carbon on this side, 1 carbon on the other side, and then we have an oxygen and an oxygen. Now, one thing I didn't tell you about, this side right here of the equation are where the reactants are. Sometimes it's called reagents. And then this side, this is the product side. So we got to get the same amount of elements on each side of this equation for the reactants as well as the product. And so far, we're balancing out. Now we're going to look at the chloride. You have a coefficient right here of 2. This is chloride. And that is 2 molecules of that. And then we have, of course, hydrogen. And we have 2 there. So if you take a look, we have 1, 2, 2, and 2. We have the same on the other side. So this is already balanced. We don't need to go any further. But I do want to just mention another thing about these numbers. Notice you have a subscript there and you have a coefficient there. You never change the subscript. That always stays the same. However, the coefficient is the thing that you can change. So as you're doing this, keep in mind that coefficients can change, but your subscripts cannot. So those are one of the a couple of rules that you need to kind of keep in mind. And really, we're just guessing. It's just guess and plug. So if I wanted to change that, maybe I think it should be 4. We can change that. But right here, do we need to change it? Well, no, because it balances already. So let's erase that. And what we're going to do, we can check our answer. And sure enough, it's already balanced. But don't ever assume it is until you've kind of gone through each of the sides, reactant side and product side. Well, let's go do another one. That one's pretty easy. Now in this one, we have, again, I'm going to draw my line. We have calcium on this side. We have nitrogen on this side. So I'm going to put calcium down here. Then I'm going to put nitrogen down here. And let's make it a little longer. Calcium on this side and nitrogen. Now again, we take a look at, we have a subscript on both sides of these. So we're going to look at, see what we can do to get a coefficient on the reactant side. So I'm going to put R for reactant on this side and P on this side for products. So on this side we have 1 calcium and 2 nitrogens. On this side, again, looking at this right here, looking at the subscript, remember, those can't change. And then we have 3 molecules of calcium, and then we have 2 of nitrogen. All right. Now, I'm just going to guess here because there's that's the thing that kind of sticks out in my mind. We have 3 calciums on the product side, and then over here we only have 1. So if I change the coefficient of the calcium to 3, it looks like that would balance, because if it does, then I would have 3 calciums and I'd have 2 nitrogens, and that way it would balance out the equation. So I'm going to go with that first. So let's erase what I've got. Let's add 3 to my coefficient of calcium. So again, it's in red over here. So if you're following along, we have 3, and that will match 3 over here on this side. We have 2 nitrogens and 2 nitrogens. So let's check my answer. And sure enough, it balances. Well, let's go ahead and do another one and practice up a little bit. Here's this next one. It's a little bit more complicated. So what I'm going to do here is I'm going to draw a line right down the middle again. We have, what is this again? What side? Yep, the reactant side. So I'm going to mark with R. And this side is that's right, the product side. So again, I'm going to write down all of these elements. I have carbon. I have hydrogen. I have oxygen. On this side, I have the same thing. Carbon, hydrogen, and oxygen. So we got to keep track of all of these. So over here on this side, again, we have a subscript. So that's only talking about the carbon element. So we have 5 over there. Again, this is 12 hydrogens, because again, talking about just the hydrogen because it's a subscript. So the hydrogen is 12. And the oxygen, we have 2 right here. That means we have 2. Going to the product side, we have 5, again, carbons, just like on the reactant side. So that looks good. Now, when you have a coefficient like that, this is 5 times 1. That would be 5. Now, because oxygen, there's 2 of them on this carbon dioxide, you'd multiply the 5 by this 2. And this 2 is a subscript. Guess have 10 oxygens. So let's draw this again. Go here. And our carbons, when we multiply the carbons, we have 5. And the oxygens, we have 10, but there's going to be more, because over here we have hydrogens. You have 12 of those. But we also have to add to the already 10 oxygens, 6 times 1. So there's 6 of those. So we have 16. So let's quickly recap what we have over here. 5 carbons, 12 hydrogens, and oxygen we have 2. We really have a big discrepancy here on the oxygens because we have 5 and 5. That's good. We have, for hydrogen, we have 12 and 12. And then we have some oxygen. We have only 2 over here on the reactant side. R. And on the oxygen side, we have 16. So I'm thinking where we can kind of balance this out is if we change this, and we're going to, if there's 2 over here and there's 16 here, I would guess we would have possibly a coefficient of 8. So 8 times 2 would be 16, and that would probably balance it. So if I did that, this would be changed to 16, which would then equal that. So this is the same, this is the same. Now by putting a coefficient of 8 over here, that should be the same. So let's go ahead and clear it and see what we've got. And I bet that by putting on my, let me see here. Let's go ahead and put this back up. If this is 8, it should balance. So let's see what we got. I can change it to an 8. And again, there you have it. It's the number in red. So we have C5H12 plus 8 oxides. That should yield 5 carbon dioxides and 6 molecules of water. So let's check the answer, and there it is. So it's kind of just that easy. But again, you have to be willing to kind of guess and compare one side to the other and see if you can make a match. And there we have it. So there are, we've done 5 of the beginners, and you should be able to see how that works. Now it's your turn to go ahead and go to the intermediate site and try your luck. And again, I would remind you, keep a piece of paper handy and do exactly what I did by dividing it in half, call one side reactant, one side product, and keep track of the elements, and then start basically guessing what coefficient would make them more balanced. And again, I think I'm pretty confident that you folks, when you practice, you're going to get better and better at it, and it'll almost become a second nature to you. So I wish you well, and I hope this has helped.